All right, guys, good morning. We are coming back from Thanksgiving break. Make sure you have out materials, work on these problems. So here we have what is the slope and what is the y-intercept. So just as a review, we've talked about this slope-intercept form before. So y equals mx plus b, where the m is your slope and then b is your y, I'll just write y-int, but it's your y-intercept. So what is the slope? What is the y-intercept? Hopefully, and I just wanted you guys to kind of work independently on this, just to kind of review. So your slope for that first one should have been -5, not 5, -5, because it's got a negative in front of it. So hopefully you identified that slope as -5. And then for our y-intercept, we've got +9 or +9. Next, we've got -2 is our slope. So hopefully you got -2, and our y-intercept is going to be +3. Next, our slope in this one is going to be -1/2, and our y-intercept is going to be +1. So hopefully you got those written down too. Again, practicing graphing these is really helpful, I think, to kind of forming an understanding of what we're doing. So again, if we have, I'm going to kind of try and make this line a little bit bigger. So we've got our x-axis and our y-axis. Remember, when graphing one of these, you start at the y-intercept and you use that slope to kind of guide you. So in this case, our y-intercept is going to be +9. So we're going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. So it would be somewhere up there. And then for a -5 slope, we would go down 1, 2, 3, 4, 5, 6. I'm sorry, not 6. Over 1. And we would have a point. And then we would go down 1, 2, 3, 4, 5 over 1. Down 5, 1, 2, 3, 4, 5 over 1. So that's going to be a pretty steep line, a -5 slope. But that's what it's going to look like. The next one's going to be kind of easier to draw, I think. So we've got our x-axis, our y-axis. I know I didn't tell you to draw these, but I kind of wanted to show you guys again how we can use the slope-intercept form to kind of plot these things on a graph. So remember, first thing we do is use that y-intercept. So we're going to mark it on our y-axis. So we've got +3 is where it starts. And then we're going to use that slope, -2, to kind of guide us. And remember, whenever you've got a whole number like that, it's just -2 over 1. So our rise is -2, our run is 1. So we're going to go down 2 over 1. Down 2 over 1. Down 2 over 1, down 2 over 1. So for this one, our line's going to look like that. All right, and last but not least, we've got this one where we got to plot our y-intercept at +1. So that's going to be right here. And then we've got a slope of -1/2. So a rise of -1 over 2. So we're going to go down 1 over 2, down 1 over 2. So far we've got these, down 1 over 2. So for this one, our line is going to look like that. And we'll have more practice with that, but I just kind of wanted to remind everybody what we've been talking about for several weeks, what we've been working on. Being able to identify slope and the y-intercept in these equations is really helpful. So just making sure we know how to do that. All right, so it's been a long time, but last time I saw you, we talked about getting a slope from a line. So when we've got a graph and we've got a line, you've got your 2 points that you pick out, doing the rise over run type of thing. So finding the slope from a line, also finding the slope from 2 points. So having 2 points on a graph and being able to find the slope using that y2 minus y1 divided by x2 over x1 formula that we've been talking about. for what seems like forever. Finding the slope from an equation. Also how to find B, something we're going to talk a little bit more about, but 1 second. Diego. How to find B. So B is our y-intercept. And then we've also talked about slope types. So positive, negative, undefined, and zero slope. So these are kind of all the things that we've been practicing, getting better at, understanding. So first of all, I just got some practice problems for us. We're going to kind of go in a different direction, and I'll explain that as we go through this. So this first problem says, what is the slope of each relationship? Which relationship has the steeper graph? So we're going to save steeper graph. We'll save this part for last. Right now, we just want to find the slope of each relationship. So I'm going to do this one first. So I is going to be first. So this says a line with the y-intercept of 0, 4, which passes through the point 4, 1. So we want to find the slope of that relationship. So we've got our 2 points. We've got this point and this point. And actually, some of you guys said it was helpful when I highlighted individual things, and I'll kind of explain that in a second. So we've got our 2 points. Remember, when we're finding that the slope with the with 2 points, we're taking y2 minus y1 divided by x2 minus x1. So that's what we're going to do for that. So I'm going to make this point number 1 and this point number 2. So I'm going to take y1, which is this right here. So y2, which is going to be positive 1, minus y1, which is going to be positive 4. And those of you who are confused where I'm getting these numbers, all I'm doing is I'm using this formula right here. I'm taking my y2 minus my y1s. So I'm taking my y values. And those of you who have consistently been to class, you guys should know, you guys should recognize what this looks like. So x comma y, x comma y. So I'm taking my y2, which is 1, and then my y1, which is 4. So 1 minus 4 divided by, and then I'm going to take x2, which is 4, minus x1, which is 0. So 1 minus 4, what is that slope, guys? So go ahead and put that in your calculators and enter that in the chat. All right, so I see Keisha put in an answer, -3/4. So 1 minus 4 is going to give us a -3. 4 minus 0 gives us 4. So our slope for that one is going to be -3/4, which is awesome. So good job, Keisha, and anybody else who got -3/4. This next one.
Thank you.
You're welcome. All right, so this next one, we're going to do the same thing. So tables and graphs, remember I've said this plenty of times this year, tables, graphs, all connected, equations are all connected. This is basically just a point. So you can pick any of these points off this graph. What I'm kind of trying to show you is we've got -4, 0. So that's a point. I'm going to use this one and this point. So I'm going to use those 2 x values, and I'm going to use these 2 y values. Okay, so I'm still using the same formula to figure it out. So, and you guys could use any of these points to figure out what the slope would be. So just letting you know that. But I'm just going to go ahead and use the top 2 just because it's easiest for me to explain. So I'm going to make this point number 2, this point number 1. It doesn't matter. You can pick either one. You just have to make sure you're keeping it consistent. So I'm going to use this as point 2. So all of my y2 and my x2 values have to come from that point. Okay, so just making sure that we're staying consistent with that. All right, so y2, that's going to be 0. So that's our y value from our point 2, or point number 2. So 0 minus y1. So 0 minus a negative 1.5 divided by, and then we've got negative 4 minus a negative 2. All right, you guys remember my little trick, or the thing that I told you guys, whenever we're subtracting a negative, that's going to be the same. Oh, and that's a point there. Sorry, I just want to make sure you guys see that. Whenever we're subtracting a negative, it's the same thing as adding. So whenever you subtract a negative, it's just like we're adding. So 0 minus a negative 1.5 is just 0 plus 1.5. So when we simplify this, it looks weird because we've got a decimal, but really we've just got 1.5 over negative 4 plus 2, which gives us negative 2. And I know typically we don't like decimals in our fractions, but really this is still representing our rise over our run. So if we were to look at these slopes in graphs, and what I want to get from today is, guys, we've been finding slope for weeks. We've been interpreting things for weeks. We've been working on just the numerical skills. This week, I want to talk more about how to apply it. So we're going to do story problems. We're going to so this says which relationship has the steeper graph. So kind of understanding what the numbers mean and how we can figure that out. So negative 3 over 4. So if I've got a graph, I probably should have put a graph on here.
I'd be okay.
But that's okay. So if we've got negative 3, 4, I'm going to go ahead, start at the origin just because, and I'm going to go down 1, 2, 3, 4 over, I'm sorry, down 3, 1, 2, 3, because it's a negative 3 over 4, 1, 2, 3, 4. So my graph is going to look something like that. Now over here, I'm going to make it a little bit bigger so we can see because the numbers are smaller. All right, so we've got 1.5, so negative 1.5 over 2. And I know it says negative over negative 2, but if we simplified that, it would just be negative 1.5 over 2. So it would still be a negative slope. So negative 1.5. So if I'm going to start at the origin, I'm going to go down 1 and then half. So down 1.5 over 1, 2. Down 1.5 over 1, 2. And it's hard for me because I can't see what you guys are doing. If you guys are writing anything, aren't writing anything, but I'm trying to show you how to kind of do this. So based on what we're seeing, which graph is steeper or which slope is steeper? I want to see what you guys think. And by steeper, I mean, think about, and if you guys aren't sure what I mean, I'm going to draw a pretty picture for you guys. I don't know if any of you guys go to Perfect North Slopes where it, you know, snows, that kind of thing. So slopes, if you're skiing, there's my little skis. If you're skiing down a hill, there's my person. There's Miss Sprunger catching on the slopes with my little skis. If I actually don't ski, I just, I have tried snowboarding, also not good at that, but I'll be on the tubes all day, that's fine, or drinking hot cocoa at the lodge. But if I was on the slope, think about and think about if you're sledding. So if you've ever been sledding before, think about which hill you want to go down. Would you want, and I typically would want to go down the one that would make me go faster, but think about steepness. So if it's not as steep, you're going to go slower. So if it's kind of like flat and gradual, I'm not going to go as fast. If it is steep, it's going to mean I'm going to drop really fast and I'm going to go really, really fast. So I know those lines look similar. They both have negative slopes, but you think is steeper?
Sketch my ear.
And it's okay if you don't know. It's kind of, and I hate to be that person, it's kind of a trick question. We've got negative 3/4, and we've got negative 1.5 over 2. If we double this one, if we double 1.5, we get 3. And if we double 2, we get 4. So if we multiplied this whole slope by 2, we would get -3/4. So they are the same slope. They are representing the same relationship. So I did just kind of want to make sure that that was clear. So there's that. I know I didn't explain that super well, but I just kind of wanted us to compare slopes and look at and understand what steepness means when we're talking about slope. So when we're talking about slope, think about how like if you're sledding or if you're going down a hill or driving down the street or skateboarding or something, down something, steepness represents how, represents like that hill, I would say. So I did want to review with you guys. I just kind of wanted to wake our brains up a little bit with that one, but I did want to go over slope types again. Remember, we've got negative slope, positive slope. Be really easy and burned into your brains at this point.
Happy birthday to me.
And then we've got a zero slope, which is going to be a flat line. And then we've got a vertical line, which is going to be straight up and down, and that's going to be undefined. We don't have a slope. Think about it. If you're driving on a flat road or going down a flat hill, there is no hill. It's just a zero slope. If you're going down a negative slope, you're going to go down the hill. If you're driving up a hill, that's going to be a positive slope. So kind of think about that as we're moving through this. All right, so I kind of wanted to talk about real world applications. One of my favorite things to talk about in math is real world applications. So this says Jameer is participating in a charity run. I don't know if you guys have ever run a 5K before or ran something, but it says Jameer is participating in a charity run. So this says for every 5 miles he runs, he will raise $30. So this is actually a lot like, our applications week. So if you were here for our algebra unit, this is a lot like what we did that week. So this is, he's participating in a charity run. For every 5 miles he runs, he will raise $30. So we want to talk about, is that proportional? Is that non-proportional? So a non-proportional relationship is going to be where you have something that makes it not straight line, not coming from the origin. So remember the very first week we talked about proportional relationships, straight lines coming from the origin. So if for every 5 miles he runs, he raises $30, we could write a table from this technically. In 10 miles, he would raise $60. In 15 miles, he would raise $75. I'm just kidding. I just wanted to see if anybody was paying attention.
I was paying attention. I'm like, that don't make sense. I was just saying, I'm like, that does not make sense. She said 30, 60, 90. I mean 30, 60, 75.
Gotcha. So what I kind of want you guys to get from this, again, it'd be easier if we were like in person, because I have some good visuals for this to show you guys. But so if something is increasing at a constant rate, so this is moving by 5s and this is moving by 30s. So this is a proportional relationship. So for this, we could write this as an equation, y equals, if you guys remember finding the constant of proportionality and everything, we talked about this several weeks ago, like at the very beginning of this unit, finding the constant of proportionality, y divided by x. 30 divided by 5 gives us 6, so y equals 6x. So that would be our relationship or our equation for something like this. And those of you who are like, how did you get that? What is happening? All we did, and this would, if you guys were here for our proportional relationship week, this should hopefully make a lot more sense. But to find our constant of proportionality or the relationship between y and x, you're just going to take your y value divided by your x value. So 30 divided by 5, which is going to give you 6. So our constant of proportionality would be 6. And then whenever we write equations for proportional relationships, we write them as y equals kx. Whenever we write equations for non-proportional relationships, we write them as y equals mx plus b. So I would definitely kind of think about this, maybe get this written down, but this is going to be for proportional relationships. So a relationship like for every 5 miles, he raises $30, something like that. So what this 6 means is for every 1 mile, he raises $6. That's what that rate means. So that's what that proportional relationship type of thing looks like. So y equals 6x. And that rate is kind of like a slope, so kind of like mx plus b, but because a proportional relationship starts at 0, 0, that plus b would kind of move us up or down the y-axis, like a y-intercept. And I'm going to try and explain this better throughout the week. But proportional relationships, y equals kx. Non-proportional relationships, y, that's supposed to be an arrow, y equals mx plus b. So that's kind of what I want us to start thinking about. So this says John is training for a bike race. If he is on his 2nd hour of biking, he is 40 kilometers from home, and on his 5th hour of biking, he is 100 kilometers from home. What is the rate at which he bikes? So a few different things going on. So he's training for a bike race. So in his 2nd hour of biking, he's 40 kilometers from home. In his 5th hour of biking, he is 100 kilometers from home. What is the rate in which he bikes? So right now, we don't know if this is a proportional relationship or not, but we can figure out the rate at which he's biking because we can actually write this. So if this were on a graph, we would have our y value and our x value. Our y value, we could make it hours. And then our y value could be kilometers, okay? So, and this, so what I want is, it's hard because it's hard to write on this thing and explain this stuff because I usually talk with my hands and I usually point at stuff, but I'm trying, guys. So if he's on his 2nd hour of biking, so if we've got 1, 2, so in his 2nd hour of biking, he's at, so let's say we've got 20 kilometers, 40 kilometers, 60, 80, 100. And then down here, we've got 1, 2, 3, 4, 5. I'm trying, I know it's messy. So for this one, in his 2nd hour, he bikes 40 kilometers. So 2nd hour, he bikes 40 kilometers. So in 2 hours, 40 kilometers. In his 5th hour of biking, so in his 5th hour of biking, he does 100 kilometers. So this is essentially the rate in which he bikes. So what I like visuals a lot, and I think I wish I kind of included a nicer, neater graph, but remember when we're finding, when those problems say find the slope of a line that passes through these 2 points, those are our 2 points. So what I kind of want you guys to think about is this is what we have been working on whenever we're finding. So hours is going to be our x value. So in our 2nd hour, so 2 comma 40, that's supposed to be 40, is our first point, and 5 comma 100 is our second point. So when we're thinking about finding slope or what is the rate, slope is the same thing of rate of change. We talked about this like several weeks ago. So slope and rate of change is the same thing. So what is the rate at which he bikes? We want to find the slope between these 2 points. So we've got our x values, we've got our y values. I'm going to write down our equation for those of you who don't have it written down or need it again. Remember, we've got m equals y2 minus y1. Oh, I'm sorry, that looks bad. Y2 minus y1 divided by x2 minus x1. All right, so I'm going to make this my point number 2. This is going to be my point number 1. We've got x, y, x, y. So I'm going to go ahead and set this up. So I'm going to take my y2 value. So the first step is to find my y2 value, which is the y value on my second point. So I'm going to have 40 minus y1. So my y value over here minus 100 divided by 2. So that's going to be my x2. So the x value on my second point minus 5. So guys, simplified, what is that? So you guys should be able to simplify that. That's going to give us our slope, or the rate in which he's biking. And once you get it, go ahead and type in the chat. So all you're doing is you're doing this top part. So the change in y, so 40 minus 100, you're going to write that on the top, and divided by the change in x, so 2 minus 5. And then you're going to simplify. So once you get that, go ahead and type it in the chat. Come on, guys. I know you haven't been in school for a while. All right, Keisha said negative 60 divided by negative 3. Ari said 20. Good. So 40 minus 100 is going to give us negative 60. 2 minus 5 gives us negative 3. So negative 60 divided by negative 3, we can simplify that. So negative 60 divided by negative 3 gives us a positive 20. So this is going to be a positive 20 over 1. So anytime we get a whole number, that's going to be over 1. And the reason for that is, remember, we write things as rise over run or y over x. So our y value, our y unit is going to be kilometers. So it's going to be 20 kilometers over our x value, which is hours. So the rate in which he bikes is 20 kilometers in 1 hour. Okay, so I'm kind of trying to get you guys to interpret what we've been using, what we've been learning, how to find the slope, and how to find kind of what we've been doing and kind of apply it to something new. And I'm gonna kind of rethink how we do this tomorrow. Let me see, I think we have some more. Ooh, Nama, you made the cut for the word problems. We'll get to it tomorrow though. I didn't realize we were running out of time already. So I do kind of want to, let me move myself, go over what is due from you guys this week. Not to review, let's see. All right, so this is your guys' class. Classwork. This week, we've got 2 assignments, no quiz again this week. Although you probably should have a quiz soon. And we are, let's see. We're probably gonna have 2 more weeks of slope and stuff, and then we're probably going to move on. So this week you've got 2 things. Finding slope practice. This should be easy peasy, hopefully. All this is, it's 3, what do you call it? 3 types of ways to find slope. So find it through points, find it from the table. So you can do table, remember this is a point. So -1, -8, that's a point. So if you need help with that, I can always help you guys. And then finding slope. So I just wanna make sure that you guys are good with finding slope. So this is just practice, how to find slope 3 different ways. And then you also have a writing assignment or a WAC. So for this writing assignment, I want you guys to reflect on your prior math classes. Tell me your experiences, good or bad. I had a teacher do this when I was in the 8th grade, and I thought it was really helpful and insightful, and it kind of helped me communicate with him a little bit better. So this says, how do you feel about math? Do you like it? Do you hate it? Does it make you nervous? What has been your best and worst math experience? So have you had a math teacher that you really loved who made it good for you? What makes a good math teacher? And again, I know this is my first year teaching at all. So, and this is also my first time ever teaching online. So I'm doing my best. So if you guys can also communicate with me what I can do to help you guys, but good or bad, I want you guys to write about your math experiences. So those are going to be you just have 2 assignments for this week, easy peasy, hopefully. So with that being said, I'm going to go ahead and stop